is McCabe. There might be another person that shows up, but for right now, my name is McCabe.
I'm Zach.
This is Zach. This is Math 1060 CBE 1 review. Just a couple things of note. This is being recorded, but you are not being recorded. It's just going to be the screens. So if you have any issues with that, please let us know after it's concluded. Secondly, if you have any questions about the PowerPoint, feel free to ask. But if you have personal questions or something like your own homework or something like maybe this will be on the test, please wait till after the CBE review is conducted, and then we can answer those afterwards. Any other questions? Okay, cool.
Sweet. So CBE covers evaluating trigonometric expressions, if I can speak English, inverse trigonometric functions, generic word problems, graphing trigonometric expressions, period, phase, magnitude, and peaks, and then graphing those.
This is our lovely unit circle. If you've ever seen some fancy TikToks or whatever that says they're the bane of your existence, it can be, but hopefully it won't end up being by the end of this class. Kind of the gist is we are kind of going away from angles and going into radians. And this is kind of your introduction to both. If we were to draw something like this triangle at where this is our theta, that could be 30 degrees, or we could say pi sixths. Our x coordinate, or how far we go on our x, is this pi thirds over 2, and then we go up 1/2. So that's how you read it. Any questions on that? Also, just one note, this is like an origin around 0, 0, right? So if we go left or if we go down, it does turn negative x and y, etc., etc. Cool.
I'm going to quickly return to this. Do any of you have trouble with remembering the unit circle? Because you will be given a blank one to fill in. I recommend you fill it in, but have you guys got it down?
Yeah, I think so.
Okay. Then I won't mess with that. You have your basic trig functions. You have sine and cosine. You have your reciprocals, where you have cosecant and secant, and then cotangent. Whoever decided that cosecant goes with sine and secant goes with cosine should be fired. Just remember it's opposite, and then tangent goes with cotangent. They are just the reciprocal, so your adjacent and hypotenuse and opposite and hypotenuse will flip as well. So it works out really nicely.
Cool. So let's do some example problems. So we got sine of 3 pi over 4. Can someone tell me what the identity or what goes over what with sine in terms of our triangles?
Opposite over hypotenuse.
Opposite over hypotenuse. So I'm going to put opposite over hypotenuse. I'm just going to do HYP. Okay. So, and we're doing 3 pi fourths. So IC on our unit circle, that is 3 pi fourths. So I'm going to draw this fun little triangle. This happens to be a 45, 45, 90 triangle. Such that, what is the kind of the fun thing with 45, 45, 90 triangles?
3, 4, 5.
Say that again?
Is it 3, 4, 5?
No. That's something slightly different. That's one of our perfect triangles with the Pythagorean identity. The fun thing with 45, 45, 90 is that the base of the triangle, both legs, are equivalent. Such that if this was 1, this would also be 1. Which makes, due to Pythagorean theorem, our hypotenuse root 2. Because 1 squared plus 1 squared is equal to 2. Square root of 2, boom. So opposite, that's going to be, if this is our theta, that's going to be 1 over root 2. It does look like our solution does like to be rationalized. So we're going to multiply by whatever root is on the bottom, basically multiply by 1, and that's going to end up giving us root 2 over 2. Any questions on that? Okay, next one, we got cosine of negative pi thirds. if we're doing negative radians, do we need to go clockwise or counterclockwise on our unit circle?
Clockwise.
Clockwise. So I need to count 4 pi thirds, but going the other way. So we have 1 negative pi third, we have 2 negative pi thirds, we have 3 negative pi thirds, and we get to this, which is negative 4 pi thirds. You could also call this angle 2 pi thirds. They are equivalent on the unit circle. Okay, so I'm going to draw another triangle. I should probably change to a different color so we're not getting it confused with the other example. Let's do blue. Okay, so we have if our hypotenuse was 1, because it is unit circle, we would need to get what on each of our sides? It does happen to be right there. So that would give us a negative 1/2 on the left, and then square root 3 over 2 on the left, or on the bigger leg, let's say that. Which for cosine we have adjacent over hypotenuse, such that if our theta is around the origin, that's going to give us a negative 1/2 over the hypotenuse of 1, which equals just negative 1/2. Any questions on that guy? Okay, and then lastly, we're ending with tangent. Is tangent opposite over adjacent or adjacent over opposite?
Adjacent over opposite.
Opposite over adjacent.
Opposite over adjacent. Cotangent is the opposite. Yeah. So this one's opposite over adjacent. And again, I'm going to switch colors just in case we have some overlap. 11 pi sixths, that's right here. So we get a hypotenuse of 1, because we're in unit circle, such that our long leg is going to be this root 3 over 2, and our short leg is this negative 1/2, such that our opposite is going to be negative 1/2 over our adjacent of root 3 over 2. How do I simplify this fraction? Or what would be kind of
Multiply by the reciprocal.
multiply by the reciprocal? So to divide by a fraction, it's actually just multiplying by the reciprocal. So I'm going to cross that out and multiply by its reciprocal, which is 2 over root 3. Those 2 will cancel out to be multiplied by 1, basically. So we get this is equivalent to negative 1 over root 3. It then asks us to rationalize, so I'm going to multiply by root 3 on the bottom, root 3 on the top. So that's going to give us negative root 3 over 3. That is our final answer. Any questions? Awesome.
We'll do, now I want to have the reciprocals. So we have cosecant. We're going to go negative 5 pi halves. So we'll go 1/2, 2 halves. I guess I'll draw 1/2, 2 halves, 3 halves, 4 halves, and then 5 halves brings us to that line. And then since it's cosecant, that we know that is just the same as 1 over sine of negative 5 pi halves. So when we look at the sine value on our unit circle of negative sine of sine of negative 5 pi halves, we're just going to get negative 1. And the hypotenuse of that is 1. We're going to erasing this is an adventure, so we're going to see if I can erase it without it changing pages. It worked. Look at that. And then with cotangent, we know that is the same as 1 over tangent of negative 2 pi. So we're going to start here. We'll go around negative pi, negative 2 pi, so we end up back here. And then tangent is 1 over opposite over adjacent, which will make it adjacent over opposite. And when we draw our line here, we are going to get something that is 1 over 0, which dividing by 0 is not something that we like to do. So the answer is does not exist because we have a line that would just shoot off to infinity geometrically. Any questions about that?
Okay, inverse trig functions. A function f is going to take inputs x and produces outputs y, such that its inverse reverses that. Where we're inputting y and we're seeing what x we would have had to plug in to get that y. Such that the input of an inverse must come from the range of the original function, and its output is going to come from its domain. Since trigonometric functions repeat, their inverse return angles come from a restricted interval, such that when we're talking about sine, we denote the inverse of sine to always be between pi halves, or negative pi halves and pi halves. Whereas cosine goes from 0 to pi, and then once again tangent shares the same range, thank you, shares the same range as sine, so tangent will also be from negative pi halves to pi halves. Any questions on that? Okay. There we go. Okay, so evaluate the following trigonometric equations. So the inverse tangent of 0. What I like to say in my brain that helps me figure this out is, what would I plug into tangent to equal 0? So this is equal to tangent of some x is equal to 0. What would I plug in into tangent to get 0? It's something between negative pi and pi halves, because that's our range of our inverse tangent function. So what would it be? Would it be 1?
It should be 0.
Oh, okay, that's what I was thinking.
Sorry, no. It's pi fourths because in order that's 0. So my brain made that a 1. Sorry, it is 0.
It is 0. Cool. My brain goes oh my gosh, I would like to draw, please.
Maybe.
The tangent equation goes like that, such that it hits 0 when it hits 0, such that this is actually equal to 0. Another way you could check that, it goes, okay, tangent at 0, that's this weird triangle that we kind of say is a triangle, but anyway.
Triangle height 0.
Yep. So that is opposite over adjacent. There's no height to it, so that's going to be equal to 0 over 1, which is 0, and that happened at 0. At radians equals 0. Okay. The inverse cosine of root 3 over 2. So we need to find somewhere within this top half where the length is equal to root 3 over 2.
Pi sixth.
You say pi sixth? Okay. Let's try it out. We have pi sixth over here. That would be adjacent over opposite. Or, sorry. Bunk, bunk, bunk. This is adjacent over opposite. Such that it would be root 3 over 2 over 1. The hypotenuse is already 1, so that's good. And our adjacent is root 3 at pi sixth. Good. So that's pi sixth. Okay, and then inverse sine Oh, I forget. It's already down there. Oh, that's also wrong. The tangent at pi. That's outside of our range. That's a typo on our part. So inverse sine of -1, that is when this is -1/1. My brain is saying that's going to be something that looks like a... Oh, wait, no. Never mind. Ignore that. That is when our hypotenuse is negative, or our opposite is -1, and our my brain's blanking. Hypotenuse is 1. Our hypotenuse is always 1, but our opposite is negative when our y is negative, such that that will be... This says -pi/2. My brain almost said 3 pi/4, but our inverse sine says that we need to do somewhere in between -pi/2 to pi/2. So that's going to be -pi/2. I almost got that wrong. Any questions on that? Okay.
I know on some of the CBE questions, they ask you to put it in the range of 0 to pi. So if you do inverse tangent or inverse cosine, you get a negative, get a negative radian value. And what you'll do is you just add pi to that to put it into the range that you want it to be in.
Yeah.
Because you'll we ended up here, but that's a negative pi/2, and they'll say, well, we want you to be in, that was horrible, 0 to pi, so they want you in the first and second quadrant. So what we can do is we can take this value and just add pi to it, which is like adding 180 degrees. You just go halfway around the circle. And I know some of the CBE questions ask for it, so it's good to keep an eye out for it. Great. Any questions about that? When I took trig, I actually was given something very similar to the unit circle, but I wrote off, and just for the first quadrant here, I wrote the values of tangent for those 3 values, because then I don't have to think about it as hard. And it's really, if you see like, oh, what's the inverse tangent of √3? You go, that's not on my unit circle. Where does that belong? If you've already calculated the tangent values, it's really easy to just go look at your unit circle and pull it up. But just something that I found helpful. And then on to functions within functions. An expression like f of g of x, the inner function g of x is evaluated first. Then the output g becomes the input of the outer function f. Basically saying you're going to follow order of operations, PEMDAS. You're going to do the stuff inside the parentheses. First, you're going to evaluate whatever g was. If g was cosine, you'll do that, and then use that value to then plug in for f. In trigonometry, the composition functions often involve trig and inverse trig functions. When the domains match correctly, these functions cancel each other out. So here we're dealing with sine and cosine, sine inverse sine. Remember, the range of inverse sine is the first and fourth quadrant. So when we say the inverse sine of 1/2, we're going to find this triangle here where the height is 1/2 and the side length is √3/2. And because you enter into this equation and you get an angle out of the inverse function, you then plug that angle directly back into the sine function, and you get the input you put into the f to the inner function. Did I lose any of you? All right. So problem 4. We have the inverse sine of the inverse sine of the 5/6. The domain, the range of the inverse sine is the first and fourth quadrant. So that triangle ends up in the first quadrant because we know sine is positive in this case. So we can just cancel out the sine and the inverse sine effectively remove each other. We end up here. Because we end up with a triangle that's like here, roughly. It's not quite pi/4, but it'd be pretty close. But since that triangle is in the first or fourth quadrant, we're okay. We can just move on. Same deal here with cosine of 5 pi/4. We're going to end up over here in the second quadrant, which we know the range of inverse cosine is the first and second quadrant, and we ended up in the second quadrant, so we're set. We don't have to think about what angle the inverse function will spit out. So it will just undo the two functions.
Isn't hyperbola in the third quadrant?
Yes. That's a good point. But the cosine of that angle still remains the same. So if we said sine of the inverse cosine of 5 pi fourths, we would have an issue of being in the third quadrant, and it would give us a negative angle because we have a negative y, we have a negative sine value, and that would put us in the fourth quadrant. That is a good point. Did I lose anybody? Oh, good. Sweet.
Cool. Once again, working with inverse trig functions. Inverse trig functions return angles, not ratios. Whereas trig functions put in angles and we got ratios. They do the opposite. Be careful that the domain of the inner function must match the allowable input of the outer function. So some g of f of x, where obviously these are trigonometric functions, the domain of the inner function must match the allowable input for the outer function. Okay. Kind of just to go over it again. Inverse sine is between negative pi halves to pi halves. That is our first and fourth quadrants. Inverse cosine is our first and second. Inverse tangent is our first and fourth. So first and fourth, first and second, first and fourth, first and second. This one's slightly different, however, because our cotangent and our tangents do not include the endpoints, like sine and cosine do. They have the closed brackets versus open brackets, so keep that in mind. Inverse secant is 0 to pi, but it cannot equal 0 or pi halves. And then cosecant inverse is, again, first and fourth quadrant, but x cannot equal 0. Yeah.
Do you know if these ranges are on the formula sheet? Let me hop in.
Let me go grab it. I'll check. It's a good question.
I'm filling that as a sub, so
It's all
I have
good.
no clue.
worries.
I don't think so.
Evaluate the following trigonometric equation. We got cotangent of cosine inverse of 2x. Hint, it asks us to do cosine squared plus sine squared of x equals 1.
It is not. In reality, if you're going to take the inverse function, you're not going to jump to cotangent, secant, or cosecant, because you can just do the reciprocal of whatever function you're trying to deal with and use one of the ones you're familiar with, because remembering the first three isn't too hard.
Yeah.
But if you, and I don't recall if your CBE actually has has inverse cotangent, secant, or cosecant. And the practices I've seen, I haven't seen one of them.
Okay.
It could appear, but I don't think it's likely.
Okay, evaluate the following of 2x. Do you want to do this one? Yeah. Cool. Thank goodness.
All right, so we're going to find out what kind of triangle we get out of 2x. Because we're going to get an angle from the inverse cosine of 2x. And we know that it is giving us a ratio of 2x over 1. And we have cosine, so we know it is the adjacent over the hypotenuse. So we have our right triangle where our hypotenuse is 1, so we're on the unit circle. Fun. And our adjacent side is 2x. Here's our theta. We don't really need to know what theta is in this case. And it'd be kind of hard to know without knowing what x was. But since we want to find the cotangent, we need to find the opposite side as well as having the adjacent side. That is a very large eraser. No, go back. There we go. And maybe black. There we go. And we can just use the Pythagorean theorem. We know that 1 squared equals 2x squared plus, call it b squared. Then we just solve for b. So we have 1 minus 4x squared equals b squared. And we'll have the square root of 1 minus 4x squared equals b. So now we know our opposite side and our adjacent side, but we want the cotangent, so we want the adjacent side over the opposite. So we're going to grab our adjacent side, will be 2, I'm going to put it up top, 2x over square root of 1 minus 4x squared. I'm going to point out really quick that, come on, give me the color I want. There we go. We have 2x here, but since we had to square both of these, that 2 got squared into a 4. Clear as mud? Success. I'll do 6 as well.
Yeah.
Cat. We're into the world of...
It's been a minute since I've done anything like that.
So now we have we know the value of secant. So secant is just the reciprocal of cosine. Why in the world are you green? Be black. So we know that 1 over the cosine of our theta is 2. If it'll let me write 2. I shouldn't have put it up top. 2 over 3. So we can construct our triangle again. We also, since we're dealing with cosine and we know cosine is positive, we know that we're either in the first or fourth quadrant. The trick is now we need to figure out whether sine is positive or negative. Here we're told that sine is less than 0, so it is negative. So we know that we're in the fourth quadrant. So cotangent will be negative and cosecant will also be negative. So let's draw out our triangle. Did I just unplug that? Wonderful. No? What have I done? There you go. Oh well, we'll leave it up. So draw out our triangle. We have cosine, so we have our hypotenuse of 3 and the adjacent side of 2. We're going to say that we have 2 squared plus b squared equals 3 squared. So we have b squared equals 9 minus 4. So b equals the root of 5. So now we have our triangle. We can just say, okay, cotangent is adjacent over hypotenuse. The adjacent is 2. The adjacent over opposite. Sorry. Adjacent over the opposite. In mathematics, we don't typically like having the square root at the bottom, so we will normalize it, although the answer down there doesn't have it. Square root of 5 over square root of 5. And you'll get 5 over 2 root 5. But both answers will be accepted on the CBE if you do end up normalizing out of habit. Cosecant is sine, which is opposite of hypotenuse, so we want the hypotenuse over adjacent because it's reciprocal. Our hypotenuse we know was 3, our adjacent was root 5, and both of these are negative. I did neglect to add the negative because we know we were in the fourth quadrant. Questions? Cool beans. Our favorite word problem. At a given time, a plane is flying at an elevation of 3,000 meters. So we know our adjacent side because it goes vertically up. At the same time, the angle of elevation from the control tower measured to the place is measured to be 62 degrees. So we know the angle of elevation of our triangle. What is the distance in meters between the plane and the control tower at the moment in time? So I personally don't really love this question because I find distance between the plane and the tower to be ambiguous. we talking about land distance or sight distance? They're looking for sight distance. So we're going to solve for the hypotenuse. We have our 62 degrees, and we know that this is 3,300 feet. So what we want to find is our hypotenuse. So we have an opposite side. We should just use sine. Remember when you use your calculators that you are in degree mode and not in radian mode, because while your calculator does default to degrees when you open it up the first time, if you ever switch during the test because you plug it into your calculator, it will remember that. So make sure when you're on your test that you, on your calculator, you see that it says DEG as opposed to RAD. So we have the sine of 62 degrees equals our opposite, 3,300, over the hypotenuse. But we want to solve for the hypotenuse, so I'm going to multiply by h on both sides. I'm going to divide by sine of 62 on both sides. So that both of the h's on the right-hand side are canceled, and the sine on the left-hand side cancel out. So we have h equals 3,300 over sine of 62 degrees. I have a calculator here. And then it was done. Sweet. So we know that the hypotenuse will be 3737.48. It does say round to the nearest whole number. So the answer we would give is 33,737. Make it okay. And we would then know if we were to shoot a laser between the tower and the plane, although don't do that, it blinds the plane, it blinds the pilots. We would know that the laser would travel just under 4,000 feet. If you ever were interested. All right, this is the fun part of this exam. Do we have a trig example, tangent example? I don't, but that one is my least favorite one. All right, so you guys learn a general equation form to solve these problems. What is it? You have your amplitude, sine, and then what goes next?
Period.
Your period.
And then phase shift.
X plus, do you write that as B?
I thought B was, is it B on phase shift? Oh, and C is the vertical change.
Then C is your vertical change. And then we know the amplitude is just A. So in this case, we know the amplitude here is 2. Our phase shift, we would have to, what would we have to do to find the phase shift?
2 pi over b.
2 pi over b. So our phase shift is, our b is pi. 2 pi over pi. So our phase shift is 2. What is the value of the horizontal shift? Pi. And then we know that the vertical shift is -3. So to draw that, we'll go down to -3. And then we know that since the amplitude is not negative, it's going to start going in a vertical fashion. The period is 2, so we're going to go over 1, 2. And then we're going to go up 2 for the amplitude. And we have our first wave. And then we can keep applying that to drawing on the screen, sorry, to try and draw that waveform. I didn't learn this way. I learned by plugging in 0 and 2 pi for this inner function here, and then figuring out all that mathematically. So this is kind of fun to learn. But this general equation works really nicely. Yes, go for it.
So in like Math 1050, whenever we would do transformations like that, for the horizontal shift, we would flip the sign. Would we do that for this one, or does it not matter because it's just across?
You are correct. We should flip the sign. So if you actually look at the answer we have here, I did go the wrong direction. But it is, we would go left and then start here and draw our, whoops. We would go left. Thank you.
Right. Anything above 2 pi though, right? Because once it repeats,
Gotcha.
it's gonna just look the same. So if that was like a 3 pi, it would act just as much as a pi would. So
Perfect.
And that would go there. So we go.
So why again are we flipping the sign?
Because you're
Because it's inside the function. So the general question that I was always taught, erase this guy. What I was always taught, well, it's actually not too black, so it'll be hard to read. I was taught, so you know the period of sine. Sine is 0 to 2 pi. So the question we want to ask ourselves is, what does x need to be to make that true? And then the same question here, what does x need to be to make this true? So you just solve for x in these cases. And then that gives you your phase shift as well as, because your phase shift will be whatever x is in this case. And then your period is just that you take this x here and subtract it from the x above. I can do that if you'd like.
Sure.
Okay. So this tablet's going to drive me nuts. All right. Why? We'll erase that when we come back.
Isn't it also if it's in the parentheses, if it's a plus it goes left and if it's a minus
Yeah.
it goes
Yeah.
right?
because once you get rid of that, like the inverse function for that, so in this case it's inverse sine,
Mhm.
right? Once you get that, to get it to the other side, you're gonna end up minusing it out. So it's actually, in terms of x, it's shifting to the left, when in terms of right, it's plus. And I use very heavy in quotations on that.
3 pi equals pi fourths x. Then this will be 12. So if you just solve for x by adding pi and then dividing by the reciprocal of pi fourths, the pi's will cancel on this guy here and end up with 4. So the initial state of the horizontal shift would be 4, and then this thing's gonna drive me nuts. And then below, if we solve for x again, we get 12. And yep. Questions? Go for it.
Okay, I'm so sorry. Can you, okay, on the period when you got the 2 pi over pi equals 2,
Yes.
where did you get those numbers from?
So we know the amplitude,
Uh-huh.
and then we get the and then your period is 2 pi over the phase shift, b. So you have 2 pi over your b,
Okay,
and then that's just the general formula.
So if it was just like regular sine, that b would just be 1.
okay,
It repeats every 2 pi, such that if we make it faster by multiplying by this pi over 4 or whatever,
uh-huh.
we need to divide it by that pi over 4.
Okay, maybe this is dumb, but you don't have to factor out, like, because in the one where, like, you wrote it up above the graph, it says, like, a sine pi, or, like, whatever, with, like, the letters and stuff. It's, like, factored out in, like, the parentheses, like, the b.
Yeah.
So, like, would we have had, like, taken a pi out of what's in the parentheses in the equation, like, or no?
So
Probably,
You can.
Probably made no sense, I'm sorry.
no, it makes sense. No worries.
Okay, okay.
So we have 2 sine, and then we'll factor out that pi fourths to get that, which means we're going to multiply that by So then we get x. We're going to have to multiply that pi by the reciprocal of pi fourths, which will give us plus 4 minus 3. Okay?
What?
That was right, correct?
I don't know, so.
I hope so.
Yeah.
The
Bye-bye.
formula for it is on the sheet.
Yes, it is.
Okay. But then now, like, you wouldn't put 2 pi over 4. Do you know what I'm saying? Because, like, that's the b value now.
Yes.
So you do the period before you were to, like, factor in.
Yes.
If you were to do that. Okay. Okay, perfect. Thank you.
That's a good question.
That is a very good question. The graphing part of the CBE is the roughest part. The one with the tangents, where you have to, if you haven't taken the practice CBE, take it. And come back, and then I'm not going to help you, because it's rough. Because they make you plot every single asymptote, also everywhere where it crosses the x-axis, and a y value. So there's a lot of things to put on the graph, and it's just a lot of work.
Okay.
Do you feel comfortable trying to do this one?
No.
Okay.
I think I missed this lesson in the 11th grade.
All right, so we have our a cosine of 3x over 2 minus 4 pi thirds. I don't know why I included the values there instead of writing them in general form, but I did it. So we know our amplitude, we can see that right away. It is 2. What is our phase shift, our period? Sorry. It'd be 2 pi over 3 over 2. 3 over 2, but we're dividing by a fraction, so we'll multiply by the reciprocal. So we're going to get 2 pi times by 2 over 3, which is 4 pi thirds. Then we have our, called it B, would be 4 pi thirds. And then our vertical shift C is 0 because it's not included. So we will switch colors to green, I guess. We have the horizontal shift of 3 pi fourths, which is a little bit bigger than 1. We're going to say it's here-ish. I don't know that value off the top of my head. It's irrational. And then our period is 2 pi thirds. So we're going to go 2 pi thirds, which is also, which would put us here. You're not going to get a question like this. You'll get questions that have whole values. This is kind of a poor example because you can't graph this nicely. And then you're going to get down here, we're going to get our waveform. That bounces back and forward. The much nicer example is the Desmos graph we have over here on the left. This guy. The best practice for graphing these is just using the CBE software to just keep, if you struggle with it, just go to the end, do the 3 graphing questions, submit, do it over again. Because it's not super intuitive how they have you put it together, and it takes a lot of practice.
Do you mind going back to the last one? Just so I can look at it.
Sweet. Yeah. Then part 2, we found the period phase shift. I wonder why they expect you to be able to graph it without knowing these outright. But that's silly. So we have our graph. Our period will be our 2 pi over the 3 pi halves, which will be that 4 pi thirds we calculated earlier. The phase shift direction is negative, which means it's going to go to the right. So it is right. The magnitude of the phase shift is going to be that 3x over 2 minus 4 pi thirds equals 0. So we have 3 over 2x equals 4 pi 4 pi thirds. We'll cancel these out, and that becomes a 2. So the phase shift y, I get 2 pi.
The phase shift is just C over B.
C over b. So isn't c 0 here?
So what's on our sheet is a sine bx minus c plus d.
Plus d.
Yeah.
We're both filling in for this, so we're going on an adventure. So what was the actual equation they have on you? So a sine
bx minus c plus d.
is the b factored out, like I wrote it earlier?
No.
No.
It's in the parentheses, and then it's the same equation for cosine as well.
Good to know. And then it would be, you said c over a?
No, it's c over b.
C over b.
Yeah.
So c over b would be,
This is for trig, right?
yep. Welcome. This is recorded, so
Alright.
you can go on our website, it's just general, so you can go back and review as well.
Okay.
We also, I personally will be working in the MLAC. If you have other questions.
Okay. Thank you.
So we end up with 4 pi thirds times by 3 halves, pow. And I got 2 pi again. I don't know if I believe that answer. Or did I didn't flip it. You should tell me when I do wrong things. I was pointing at her.
It's all good.
So we have 4 pi thirds times by 2 over 3, which is 8 pi ninths. There we go. The number of, after graphing it, now counting the number of peaks on the interval, I'm going to assume they mean 0 to 2 pi. They don't say so, but that's typically what the question asks. We find 1, 2, and 3 over that interval.
So when you're solving for the magnitude of phase shift, are you just solving for, like, what part of the graph are you solving for? Sorry. Is it just the phase shift?
It's just the phase shift, and it is just factoring, it is just this c over b. Or if you factor out this b, so we have that bx plus c. If we factor out the b, we'll get that b times this, which is why I wrote out the factored form earlier, which makes more sense. But this would give you the magnitude of the phase shift, but you have to factor out the b.
Gotcha.
Janet's on the second floor at 55 dollars. No, she's on the third floor.
All right.
Rio.
Problem 10. And then here's do we have it graphed? We do. So we have our tangent. So we have a tan bx plus c plus d. We know the amplitude, so what that tells us, if we were just dealing with tangent as it was normally, if we didn't have any phase shift or anything happening, we would go over 1 and then we'd go up to 5. So that's the point that we know about. So we would be able to, that's one of the points we can graph. What I'm trying to say.
That's the amplitude.
That's the amplitude. Doesn't make sense in tangent because it does shoot off towards infinity, but it's the over 1, up 1 idea of tangent.
Okay.
We have no vertical shift. So we know our amplitude is 5. we can find our phase shift, that is that 2 pi over 8, or 2 pi times 8 pi, which is 16. So it'd be 8.
It's because when you use tangent, you just do the pi over b.
Pi over b? Oh yeah, because it's periodical with pi as opposed to 2 pi. Thank you.
University, higher education buildings.
So just pi over.
How these things are ranked.
So then the pi's cancel, and we will just get 8.
No, that was ranking of primary. So
So these pi's will cancel. So we know the phase shift, we know the direction is positive to the right, and there's no vertical shift. So since we know that we are going to take this shift to the right by 8, we will pick our force point here, and then we'll do our over 1 up 5, over 1 down 5. And this would happen every, so 8 to 4, so there's a asymptote at 4, and then it would appear again at, so we have our,
So I think the problem is that the p represents the period and the phase shift is the c over b, which is 2.
C over 2, which is our pi fourths over 2, which will give us,
Well, it would be pi fourths over pi eighths, which is 2.
thank you. Which is, so our starting point would be 2.
he was talking, we were just checking out. I didn't like so.
So 2 over 1 up 5, 1 down 5,
Let's get it taken over.
1 down 5 right there. And then our period would be over here to 4. Is, no, over there to 2 plus 4 is 6. So our asymptote should be at 6.
I feel like you know it.
I don't have any that's memorized, and that's why.
All right.
I think that's the only thing I do.
So a vertical line wherever. So a vertical line where the has an asymptote for on 10 to 10, which is the question. So we know that since our shift was at 2 and the period was 8, we're going to go over half of that. We're going to have an asymptote, and over every 8, we're going to have another point across the x-axis. So every 4 from every point, we're going to have an asymptote. And then every plus or minus 8 from 2 will have another point. And then it'll ask you to graph this 5 from the amplitude I mentioned earlier as well. For all of those, but there wouldn't be one over here because it cuts off at 10.
And then if there was a d value, it would just move
It would just add,
everything up or down.
yeah, it would just do a vertical shift up or down. Although they would still ask you about the x-intercepts. So if they give you one like that, it's probably just going to be 1 or 2 and there won't be an amplitude to it. Because otherwise finding those values is very difficult.
So they should be pretty
Yep.
nice numbers.
I don't
So if you're
think
getting
you're going to
crazy
have a
numbers, it's
vertical
probably
shift.
wrong.
Yeah. Otherwise these questions get very difficult very quickly.
So you don't think there's gonna be a vertical shift?
If you do find one,
Unless if it happens to be one where it's the amplitude shift, where it's up on that line.
Yeah.
Thank you guys.
Of course,
Yeah.
like we said earlier, this is recorded, and it's there at usu.edu/math/amlec.
There's
And
videos from previous semesters on there. This CBE is pretty new. It started last semester, so there's only one video there. We're just trying to get these videos up. So please go there. Or if you have any other classes like Calc 1, something other with the CBE, we also have CBE reviews for those classes too. So yeah.
I will be in the AMLEC and also the